All right, in this video, we're going to take a look at a percentage application. We're going to take a look at discounts and markups. So discounts are going to refer to sale prices. So when we take a discount on something, often at a store, we're taking a percentage off to get a new price, and that new price is the sale price. So we would refer to the beginning price as the original price of the item, and then when we take off the money or we applied the discount, we would end up with what we'd call the sale price. A markup is an increase which gives us retail price. So what happens is stores pay what's called wholesale price. So they buy it from the company for what is called wholesale, and then they mark it up, which is an increase to make the price that they sell to you, because they want to make money as well. So everyone kind of marks it higher so that they make money. So a markup is an increase, and a discount is a decrease. So when we think about an increase, it should get larger in value. A decrease should get smaller in value. And we have kind of our formal definitions here. So a discount is a decrease in the original price of the item, and a markup explains to make profit, stores charge more than what they pay. This increase from what the store pays to the selling price is called the markup. So let's go ahead and find some prices after a discount or markup. Example 1, finding a sale price after a discount. The original price of a pair of shoes is $80. The sign says 30% off. What is the sale price? So we're looking for the price after we take 30% off. Two methods. Method 1 is how we have typically found percentages and a decrease previously. So I want 30% off. So what I need to do is I need to find 30% of 80. We can use that with the percentage proportion, or we can do that with the percent equation. I'm going to use the percent equation. So I'm going to change 30% to a decimal. Of is multiplication of 80. So 30% of 80 is 24. Now 24 is not what we pay, it's what we take off. What we take off. It's how much we're saving. We're saving $24. So the second part, so this was step 1. Step 2, we're going to take our original price, $80, and we're going to subtract our $24 to find our final sale price, $56. So that is the final. That's our sale price. Method 2, we're going to apply the percentage in a little different idea. Method 2, so we're doing a discount. Now, if we're doing a discount, we're taking the percentage off. Now, we want to think if we paid full price. If we pay full price, we're paying the whole. So we're paying 100% of the price. If I take 30% off, I'm going to take my full price, 100% of it, and I'm going to take away 30% of it, leaving me with 70%. This is the amount of the price, or the percentage of the original price that we are going to pay. So we've already kind of applied our discount. So now in step 2, we want to find what 70%, we want to know what 70% of $80 is, because that's how much of the price we're paying. So now I'm going to convert this to a decimal. Of is multiplication of 80, which gives me $56, which is the same price we got with method 1. Method 2 has its advantages, and method 1 has its advantages. So method 1 is kind of how we've thought about percentages all along. Method 2, the advantage to method 2 is we're going to subtract from 100 every time, because 100 is the original or the whole price. Subtracting from 100 is very simple math. It's more basic math than these calculations we have to do here, which are sometimes are easier, but can be a little more distracting in keeping track of values. Whereas 100 minus a value, we can do mentally. And then we can multiply to find our final. So I prefer method 2. That's the way that I'm going to continue to do these types of problems in the future. All right, let's look at example 2. Finding a retail price. So this was we're applying a markup. So I'm going to make note that we're going to do a markup. So the price is an increase. Method 1. A furniture store, or excuse me, let me read the problem. A furniture store that sells sofas buys them from a manufacturer at a wholesale price of $350. So that's what the store is paying for it. The store then marks it up 80%. What is the retail price of the sofa? So method 1, we would find 80% of 350. So 80% of 350, because that is how much it will increase. So 0.80 times 350 gives me an amount of $280. This is the amount they're going to increase it by. So I have to remember to take my $350 and increase it by $280, giving me an amount of $630. So we found out how much it was going to go up by, and then we had to do the last part of increasing it by that amount. Method 2. Method 2, remember, so we're doing an increase. So $350 is 100% of the price. So here I'm starting with 100% like we did before. But now because it's a markup, we're going to add our 80%. In the previous problem, we subtracted because it was a discount. So now we're dealing with an increase, so we're going to add. So that's going to determine what operation we're doing to our 100%. This gives me an amount of 180%. All right, so then the last step is I have to multiply. I have to find what 180% of 350 is. So 1.8 times 350 is going to give me an amount of 630, which should be the same from method 1. All right, let's do a quick just study tip, kind of dealing with this value here and this value here. A 25% discount is the same as paying 75% of the price. That kind of helps us determine that multiplier, or what we're multiplying by in method 2. So if we had a 30% discount, we would do 100% minus 30%, giving us 70% as a multiplier of 0.70. Now, because this is mental math, getting from this value to this value to this value, if we go right here, that's fine. We don't have to explicitly show these subtraction from 100. That's why I like method 2, that we don't have to show that type of work. If it's a markup, it's an increase. So we would take 100%. We would add our 70%, giving us 170%, 1.70 as a multiplier. All right, we're going to go to the back here, and we're going to look at example 3. Finding an original price. A new power drill is 40% off and is now $70. What was the original price? All right, so if we think about this, we have an original price. It went down with the discount and is now $70. So we have to go backwards. We have to get here. Now, it's very common that students think, okay, we went down 40%, so we just got to go up 40%. We need to increase it by 40%. But we have to keep in mind that going down a percentage and then increasing back that percentage or vice versa do not result in equivalent values, because the percentage of the whole is changing. So the part is a different size. So we want to ask ourselves really in this question, if you're taking 40% off, what percent of the original are you paying? Let's think about that. If I take 40% off, so if I do 100% minus 40%, I paid 60%. That's the key to this problem. 60% of the whole is what I paid, which is $70. So let's think about that. 60%, so 0.60 times my price is going to equal $70. Now we have this, so I use the percent equation. So if I wanted to solve this, I would just divide by 0.6 on both sides. So I'm going to divide by 0.60 so that these cancel and I'm left with x. And I got to do it on both sides. End up with x equals about $116.67. And because I rounded, I'm going to put the approximate symbol there. Another way we could have set this up is the same idea. We could use the percent proportion. So we could say 60% of what number is 70? And we could have solved that as well. Let's look at two more examples of that. So the discount on a DVD is 50%. It is on sale for $10. What is the original price of the DVD? Okay, so if we can kind of think about this one a little logically. If 50% off gets me 10, 50% is what I'm paying, the other 50%. So I'm trying to think, okay, 50% of what number is 10? That one's a little easier. X equals 20. So it's a $20 original price. Mr. Reeson paid $600 to have a tree removed in his yard. This was 40% cheaper than it would have been in the summer. How much was it in the summer? Okay, so I'm taking 40% off. So I paid 60% of the price. So I paid 60%, and this is actually the same percentage, so it should work out very similar. 60% of what number is 600? And then we would divide both sides. I would get 600 divided by 0.6, which is going to leave me with, hopefully you've caught it already, $1,000. And it should make sense that the original price should be larger than what the sale price was. If we were to change this problem, let's say I made this a 75% off. Now we would be paying 25% of the price. So how that would change is it would be 25% of the price is $600. And now when we solve that, 600 divided by 0.25 leaves us with an X value of 2,400. And this is how we can work with the application of original price, sale price markups. So I hope this helps.